as our moon. The first planet we can now see is Mercury. During the day, temperatures on Mercury's surface can reach 800 degrees Fahrenheit because the planet has no atmosphere to retain that heat. Nighttime temperatures on the surface can drop to minus 290 degrees Fahrenheit. The next planet is Venus, second planet from the Sun and sixth in the solar system, in size and mass. At its nearest, the planet's surface temperature is about 900 degrees Fahrenheit, 465 degrees Celsius, hot enough to melt lead. Mars is the fourth planet from the Sun, and is the second smallest planet in the solar system. Named after the Roman god of war, Mars is also often described as the red planet due to its reddish appearance. Mars is a terrestrial planet with a thin atmosphere, composed primarily of carbon dioxide. If you swipe to the right, here comes the massive Jupiter. This is the largest planet in the solar system and is the fifth planet out from the Sun. It is 2.5 times more massive than all the other planets in the solar system combined. It is made primarily of gases, and is therefore known as a gas giant. Jupiter has the shortest day of all the planets. It turns on its axis once every 9 hours and 55 minutes. The rapid rotation flattens the planet slightly, giving it an oblate shape. Jupiter has unique cloud features. The upper atmosphere of Jupiter is divided into cloud belts and zones. They are made primarily of ammonia crystals, sulfur, and mixtures of the two compounds. The Great Red Spot is a huge storm on Jupiter. It has raged for at least 350 years. It is so large that 3 Earths could fit inside it. Now if you swipe to the left, Saturn is best known for its fabulous ring system. Saturn is the sixth planet from the Sun and the second largest in our solar system. Like Jupiter, Saturn is a gas giant and is composed of similar gases including hydrogen, helium and methane. Saturn is the most distant planet that can be seen with the naked eye. It is the fifth brightest object in the solar system and is also easily studied through binoculars or a small telescope. Saturn's rings are made up of billions of particles that range in size from tiny dust grains to objects as large as mountains. These are made up of chunks of ice and rock, believed to have come from asteroids, comets, or even moons, that broke apart before they reached the planet. Now swipe to the right and you can see Uranus. This is the seventh planet from the Sun. It's not visible to the naked eye, and became the first planet discovered with the use of a telescope. Uranus is tipped over on its side with an axial tilt of 98 degrees. It is often described as rolling around the Sun on its side. Uranus turns on its axis once every 17 hours, 14 minutes. The planet rotates in a retrograde direction, opposite to the way Earth and most other planets turn. Now here comes Neptune. This is the 8th planet from the Sun, making it the most distant in the solar system. This gas giant may have formed much closer to the Sun in the early solar system history, before migrating out to its current position. Like Uranus, Neptune has an incredibly thick atmosphere comprised of 74% hydrogen, 25% helium and approximately 1% methane. Its atmosphere also contains clouds and the fastest winds recorded in the solar system. Particles of icy methane and minor gases in the extremities of the atmosphere give Neptune its deep blue color. The striking blue and white features of Neptune also help to distinguish it from Uranus. The formation of the solar system. Although there is some debate as to the solar system's formation, the following outline is currently the best known explanation of how the solar system developed. Approximately 4.6 billion years ago, a large cloud of gas and dust was disturbed by some force. Scientists have theorized that this force was a nearby supernova. As a result of this disturbance, and the energy introduced to the cloud began to move. Once the movement began, the cloud started to collapse in on itself due to its own gravity. During the process of collapsing, the cloud began to rotate and heat up. As the cloud continued to collapse, the cloud's temperature continued to rise, and its rotation became faster and faster. As a result, the cloud eventually began to flatten out into a disk shape, with most of the mass located at its center. At some point, the pressure and temperature became so great at the cloud into tiny particles. As more and more particles formed, they began to collide with one another and stick together, thus creating particles as large as rocks and boulders, or comets. Over time, the orbits of the planets and other bodies stabilized into the solar system that we know today. How will the solar system die? In about 5 billion years, the sun will run out of hydrogen. Our star is currently in the most stable phase of its life cycle and has been since the birth of our solar system, about 4.5 billion years ago. Once all the hydrogen gets used up, the sun will grow out of this stable phase. With no hydrogen left to fuse in the core, a shell of fusion hydrogen will form around the helium-filled core, astrophysicist Gillian Scudder wrote in an article for The Conversation. Gravitational forces will take over, compressing the core and allowing the rest of the sun to expand.